A prefabricated house, put together in only 2 days.
Incredible how fast the first floor of the house has been put up. Amazing.
Despite their experience, minor mishaps occur, problems with the roof.
It's a design fault. I can't get the roof section over any further.
The agony of choice, choosing the interior design, a real marathon task.
After a whole day, your head's spinning.
3 buildings a day, prefab houses on the assembly line, using wood from local forests. Special equipment in action. This harvester cuts down more than 100 trees a day in all weather conditions. Cold is the sawmill's worst enemy. The machines grind to a halt.
What's wrong?
Axles are clogged with sawdust.
Yeah, we'll have to blow it out.
Okay.
And the premiere on the building site. The first tour around the new house with the whole family. A construction site in the Swabian town of Sigmaringendorf. But it's no ordinary site. In only 2 days' time, a prefab home will be standing here. The truck-mounted crane lifts the first external wall over the scaffolding. Luckily, there's no wind, so the 2-ton element doesn't start swinging. But it's freezing cold. The construction team has to take care not to slip on the icy floor slab foil. The men guide the first prefab wall to its designated position and attach supports so it doesn't fall over. The problem, however,
Conditions are extremely cold this morning, minus 14 or 15 degrees Celsius. The mist's gradually falling and it's very slippy. That makes it more difficult to set up the first wall because it can slip away in any direction.
the second wall is carried in. After that, nothing should be able to slip anymore. A fitter pulls the top corners together using a ratchet. Prefabricated assembly openings make it easy to bolt the walls together. Crowbars are then used to align the walls precisely. Unfortunately, it doesn't work properly on the icy foil.
The problem at the moment is that because the foil is so slippery, the crowbars can hardly get any leverage on the walls. So now we have to attach a bracket and use bolts to get the walls into the right position.
Rebecca and Klaus Bissinger are the proud owners of this prefab house. They've come along today so they can watch everything as it happens.
We've taken the day off to be here because it's just so amazing. We hardly slept all night.
After a short time, all 4 external walls are in place, but things move on right away. The crane now lifts the first inside wall over the scaffolding.
We've measured where it's going to go. This time we've marked it with tape and now we're going to put the bolts in. Then we'll lower the wall that's hanging up there down into position.
The component is lowered carefully.
Okay, release it.
Carefully fitted over the bolts. Washers placed beneath the bolt heads. Bolts tightened up and finished. The first inside wall is in place. The team follow the same procedure to install the rest of the interior walls. 5 hours later, the ground floor is completed. Time for a break. House owner Klaus Bissinger provides a little refreshment for the construction team. While the sausages are warming up, the physiotherapist and his wife step into the ground floor of their new home for the first time.
It was impressive how fast they managed to put up the ground floor in a single morning. Unbelievable. It looks so much bigger now than on the bare floor slab. There it looked as if there was only a living room and nothing else. But now you can see the separate rooms, like the kitchen back here, the dining room with all the stuff in it, and then the living room here. All we need now is the wood burner. That's quite urgent.
The men from the construction team are hungry, but the owner is so enthralled by his new prefab house that he's forgotten about their lunch. So the team will now just have to make do with burst sausages. But as long as they can warm themselves up a bit and have a bite to eat, it doesn't really matter. A brief look back. This housing estate in nearby Mengen is where Rebecca and Klaus Bissinger live with their 2 daughters. For the family of 4, the rented apartment has gradually become too small. The Bissingers have been thinking about having their own house built for a number of years. In the end, their decision was clear: a prefab home, right in line with the current trend. 1 in 5 single-family homes built in Germany is now a prefabricated construction. The house builders are spoiled for choice. Over 100 companies are competing for customers with thousands of different variants. For example, gable roofs, hip roofs, pent roofs, cube-shaped with flat roofs, facades with plaster, with wood or with stone finishes, or with lots of glass. There are also very different designs. For example, prefab houses with ready-made brick walls, wooden houses in block design, half-timber designs, or in timber frame style. The interior design ranges from generously modern right up to cozily rustic. One of the largest prefab home manufacturers in Germany is based in the Swabian town of Hohenstein-Oberstetten. The gigantic site measures 490,000 square meters. That's roughly the equivalent of 70 soccer fields. In these enormous halls, around 900 prefab houses are produced every year. One of these will soon be the Bissinger's new home. They've chosen a turnkey solution. That means they have to select every single detail of their future home before production can even begin. Interior design consultant Ellen Rauscher takes them through the giant furnishing center.
Let's start right at the top of the house with the roof tiles. The one you can see on the far right is a natural red slate, which doesn't have any glazing. You can tell because it's not as shiny as the one next to it in copper red. And these tiles here, that are even shinier, are coated with a much better high-quality glazing. That means there'll be much less moss formation on the tiles.
Copper red one, but with the glazing.
Yes, the glazed one.
The choice of color for the exterior plaster and for the front door is also made quickly. Next, it's the patio doors. There are 2 different systems to choose from.
The difference between the 2 versions is that this one has a very high threshold, and with the lift and slide version, the threshold is relatively low, and that's easier for walking in and out.
Personally, I like that one better.
So do I. It runs a lot easier.
But it's also a bit more expensive than the other one.
Ultimately, of course, you have to make sure that you don't end up going over your budget. Depending on what fixtures and fittings you choose, it can often mean over 10,000 euros or more of additional costs.
Because the Bissingers have been thinking intensively about building their new home for 5 years, they already have clear ideas for many of the details. For the doors, for instance, the door handles, for sockets and switches, the floor coverings for the various rooms, for the stairs to the upper floor, and for the wall tiles in the bathroom. However, with the enormous range available, the couple find choosing their bathroom furnishings a real challenge. Some bathroom designs can be ruled out immediately, simply because of their size.
We need an extension. We just don't have that much space. It wouldn't look as good with a washing machine up there as well.
While other designs are not really their taste.
No, that's not really us, is it?
I can't sell you this one.
No.
What a shame.
Eventually, they find a bathroom that's also at the right price. The only question is whether the tub is big enough.
Good. It's good? Not too small? No, it's just right.
Don't go in with high heels on at home. We chose that one because it's a more angular shape, and the wash basins are rectangular and don't have the deep rounded shape at the bottom, but are just flat and straight. So we'll be able to fit matching base units underneath them.
The Bisinger's bathroom won't have any radiators, and neither will the other rooms.
The radiator takes the air it needs from the room. The warm air gives off heat to the heat exchanger. Fresh air flows in from outside and is heated up by the warm used air from the rooms, and this gives you a basic temperature in the house.
And this is the small heat pump right here?
Yes, that's the small heat pump, and that gives you additional heating performance if you want it warmer than the basic temperature setting.
After 8 hours, it's all over. Countless choices and decisions have been made.
That was pretty intense because normally 2 days are scheduled. But because of my physio practice, we just don't have the time to spread it over 2 days, and after a whole day, your head's just spinning.
The most important building material for the house is spruce wood. The plant here processes a gigantic 80,000 solid square meters a year. Around 12,000 of them are sourced locally in the forests around Sigmaringen at the southern end of the Swabian Alb. Today, the forestry workers will be thinning out this section of forest. Stefan Fischer from the forestry department marks the trees which are to be felled. Those standing too close to others, for example.
You can see here that the crowns of these two trees are already touching, so we'll take this tree out to allow the crowns of the remaining trees to spread out better.
The trees are felled by this monster on wheels, an all-wheel drive harvester, 8 meters long, 3 meters wide, weighing 22 tons. Each of the rear tires are 71 centimeters wide to prevent the harvester sinking too deeply into the forest floor and destroying the fine roots in the soil. For harvester driver Lars Koch, frozen ground makes ideal conditions, just like today. A tree is cut down more or less every minute. On muddy or marshy land, however, it takes a little longer.
In the forest, ground conditions play a very important role. If it rains for days on end, you sink in by up to 40-50 centimeters. And our guidelines say we shouldn't carry on driving if we sink in by more than 40 centimeters. For that, we have aids on the front tires, the so-called caterpillar tracks. With them, the pressure on the ground is more evenly distributed, and you're allowed to drive much longer in bad weather.
The trees here are about 40 meters high. The harvester first secures the trunk with its harvester head and then saws through it at the bottom with a hydraulic chainsaw, then pushes it over. With feed rollers, the harvester head pulls the trunks through 5 blades that remove the branches. Every 5 meters, the feed rollers stop and the trunk is sawn off. Depending on the kind of wood, this 500,000 euro harvester can process about 12 trees an hour. Now, the next monster goes into action. This 4-axle all-wheel drive vehicle is a so-called forwarder. It collects all the logs, takes them to the collection point, and stacks them in piles.
Take the saw, hammer, wedge, everything we need.
On this slope, however, the big machines can't operate. Here, the forestry workers have to cut down the trees the traditional way, by hand. The challenge is that the marked spruces they cut down must not damage any other trees.
This one's going down there, right?
Right, and if you can't get through it, if it gets stuck, we'll pull it down with the caterpillar.
Okay.
Yeah, it might get stuck because of all the frost and snow.
The man saws a notch into the tree that's coming down. This determines the direction of the fall. He then saws all around the trunk, but not all the way through. The wedge is used to stop the tree falling towards the men.
Watch out!
One final cut, and down comes the tree. It lands perfectly. Rather less than perfect is the quality of the trunk.
The tree's rotten in the lower section, so we'll cut a 2-meter piece off the end.
The dreaded red rot means this wood can't be used for prefab houses.
So now it's good. Nice and white. Perfect.
Now the special caterpillar comes into play. It pulls the freshly sawn wood off the slope. Costing 100,000 euros, this machine has a 55 horsepower diesel engine and can negotiate slopes of up to 45 degrees. And its special feature is that it's remote controlled. At the collection point, the municipal forestry workers are measuring the quantity of timber. Timber intake is the technical term. First, Jürgen Kohler counts the tree trunks.
We draw a long line after every 50 logs so we can count them better. And when we finish marking them, we count up the long lines plus what's left over.
That makes 158 altogether. Now, Stefan Fischer measures the diameter of the top logs. The digital caliper stores the data, determines the average log volume, and multiplies the result by the total number of logs. In this case, 158.
41 cubic meters.
41.446 cubic meters.
So now they're getting our seal of approval. That shows that our wood's been sourced from sustainable forestry. It basically means that we never use more wood than we can grow back in a certain period of time.
The roundwood timber purchaser from the Prefab house company arrives. Georg Tiggermann carries out quality spot checks even as the trees are being felled.
How old is the wood?
It's over 90 years old.
Over 90. That's good. And how much can we expect to get from this harvest?
From this one, you'll probably get over 400 cubic meters.
When wood comes from an 80 to 100-year-old tree population like this and has reached this size, for me it's a sign that it's grown slowly, has a narrow ring structure, and a certain wood density that's very good for what we need it for. If these logs had a much larger diameter, we'd see very wide annual rings, very hard knots, and consequently a kind of wood that in terms of strength and hardness wouldn't be suitable for our products.
Haulage contractor Bernd Gulde now loads the wood onto his 40-ton all-wheel drive truck. Bernd Gulde is allowed to carry 22.5 tons. He has no scales. Here in the forest, it's experience that counts.
Theoretically, I've still got some space at the top, but the wood's quite heavy, so I haven't used the full loading height.
Fortunately, the forest tracks are frozen solid today. Longer frost-free periods in winter can lead to problems for transporting the wood.
It can sometimes happen that you get stuck and need help. Someone to pull you out with a winch or another truck. It's quite rare, but it does happen.
Today, everything goes smoothly. It's around 35 kilometers to the Prefab house company in Hohenstein-Oberstetten. After just under an hour's drive, Bernd Gulde arrives with his cargo. He unloads it at the roundwood timber loading bay, where the logs undergo another quality inspection.
There are various timber qualities. B is very good, C is medium, and D is poor quality.
A quality is strong timber that only comes from long tree trunks and is used for veneers. The ideal wood for prefabricated houses is B quality. It has grown straight, has the core exactly in the center, and has very few knots. If a log is much thicker on one side than on the other, perhaps because the root base is still attached, the thicker part is milled off, because wood of even thickness is much easier to process. The color of the wood is also important.
On this log here, you can see from the difference in color that it's rotten. Red rot. That's why we'll go down to D quality for this one.
In other words, unsuitable for house building. The log is rejected. The next stop for the spruce wood is the debarking machine, a tube containing 6 rotating blades known as finishing knives. Michael Ama, the sawmill production manager, inspects the machine regularly. To do so, he stops the conveyor and takes a very close look inside the machine.
The blades are perfect, as good as new. Normally we change them every 6 months, but we also carry out regular inspections. We'll have a look inside every week and any broken ones are replaced.
The next inspection point determines the precise volume of wood the supplier has delivered to the plant. A 3D laser measures the logs fully automatically. Length and thickness give you the volume for each log. Volume and quality are the factors that determine how much the supplier gets for his wood. Based on this laser-determined data, the logs are then sorted into huge stacking containers. The company premises hold a permanent stock of around 60,000 solid cubic meters of timber, all of it spruce. The entire annual demand is about 200,000 solid cubic meters. After processing, around 120,000 go to timber wholesalers and 80,000 to the prefab housing industry. A gantry crane lifts the logs onto the sawmill's in-feed conveyor. The mill has 2 sawing lines. The heavy timber line processes logs of 20 to 68 centimeters in diameter and has a daily capacity of around 700 solid cubic meters. The saw first removes the rounded slab edges on the right and left of the log. It's then turned onto the flat side and runs back through the machine once again. The 2 remaining slab edges are removed, and the now rectangular log is sawn into boards. The slab edges, however, are certainly not wasted. They are put through this so-called trimming machine. It scans each slab edge individually to enable it to cut out the optimum board with a minimum of waste.
This shows it quite well. This here is the board, and at the sides is the bark. The machine itself decides automatically what product it makes from this.
Some of these boards will be used for the prefab house. The rest will be sold and processed further into packaging materials like boxes or pallets, for example. Suddenly, there's a malfunction. The machine stops. Michael Ama hurries to the saw.
What's wrong?
The axles are clogged up.
With sawdust?
Yeah.
Okay. This is much more of a problem in winter, of course, because of the temperature. At -15, the sawdust can sometimes freeze right onto one of these feeder axles and build up until it clogs it up. So then we have to knock it off or blow it away with an air hose.
It takes about 5 minutes to blow out the entire chamber with its enormous saw blades. Then the machine can be started up again. The processed boards run along a conveyor belt to a visual inspection. Here, they are separated into 3 quality categories. Quality 1 is not marked. Quality 2 is marked with a line. And Quality 3 gets 2 lines.
Here we can see the rod. That's Quality 3. And Quality 3 can't be used for a house. Quality 2 is what we use as solid wood material in timber frame construction for walls, interior walls or other things.
Wood residues, sawdust and chippings are used to make chipboard, wood pellets, paper and cardboard. Not even the waste wood gets thrown away. It's burned as fuel in the company's own cogeneration power plant, which feeds twice as much energy into the grid as the entire factory uses. The boards from the sawmill have meanwhile been stacked, but they still can't be used to make elements for prefab homes because they're too moist. So they're now put into one of 27 computer-controlled drying kilns that hold between 50 and 2,000 cubic meters. Before drying, the staff drills sensors into the wood.
Electricity is passed through one sensor. The more moisture in the wood, the easier the electricity is conducted from one sensor to the next. The computer needs this data to control the drying process and to determine when the wood is dry enough to be used in some of our prefab houses.
If the wood were used while still moist, it would gradually warp, form cracks, and may even become infested with insects. Rainer Henninger now brings along a second measuring instrument.
Using this, we determine the humidity in the air. When the air reaches its maximum saturation level due to the water coming out of the wood, it's detected by this device. The flaps on the kiln roof are opened, the saturated air is released, and fresh air flows in from the back.
This process is repeated until the timber only has a moisture level of 13%. That takes up to 2 weeks. Let's look back. The Bisingas have already put their dream house together on the computer. This is what it should look like: 2 floors with a hip roof. They had already drawn up the floor plan themselves, and then the architect from the prefab company took over.
We worked on the floor plans with him and put the layout together just the way we have it now. And then he gave us a 3-dimensional picture of what it could look like when it's finished. There will be a few color changes, because that color scheme's not really our style.
The building plot is 8 kilometers away in Sigmaringendorf, right next door to Klaus Bisinger's parents' house.
My grandfather's old workshed used to be here. We knocked that down, and the walls you see there are still the old interior walls, but we've left them standing as retaining walls for the slope.
One benefit of wooden prefab houses is that you can put them up in winter as well. The floor slab is already finished, and all the connections are in place.
We wanted to build a cellar here, but the problem is there's a huge rock underneath the ground here. And we would have had to remove that, either by blasting or chiseling it out. The high costs meant that we couldn't do that. So we went back to the idea of a floor slab.
This measures 8.5 by 12.5 meters. However, at the moment, the bare slab doesn't look that big to the clients.
Like this, it looks very small, but perhaps later, with a house?
Well, at first I thought it'll do for a big living room, perhaps with a dining room as well. But for an entire house, it does look a bit small.
Back at the Prefab House Company, the wood for the Bisinga's home is now dry and is taken for refinement to the so-called glue lamination hall. It's enormous, 16,000 square meters, the size of 2 soccer fields. Here, too, the first job is sorting. Boards that have warped during drying are not suitable for constructing prefab house elements. They don't make the cut, so to speak. The good quality boards are then planed on all 4 sides and passed onto the X-ray machine, which detects knots in the wood. As they represent weak points that could cause the wood to break, they are cut out by a special computer-controlled miter saw. The different sized boards are now joined together into uniform 26-meter lengths in the so-called finger jointing process. A milling machine cuts interlocking tapered profiles, the so-called fingers, into both board ends. Glue is applied to one end and hardener to the other fully automatically. The machine then presses the two ends together for 2 seconds. After an hour, the bonded section has hardened, and after 24 hours, it's weatherproof. The next machine processes the finger-jointed boards into so-called glulam beams. Glue and hardener are applied once more to the first board. Every second board remains dry. A conveyor now stacks the boards up in a pressure chamber, where several duo beams are produced simultaneously, each consisting of 2 boards. Always one board without glue on top of one board with glue. Once the chamber is full, the clamps at the top close. Steel blocks on hydraulic rams rise up and press the boards together at a pressure of 1 Newton per square millimeter of wood. This process takes an hour. Then the finished duo beams leave the press. They are the basic material for timber frame prefabricated homes. Before being cut to size and milled for each individual house, they're put through a planing machine. In the design department, the staff is now planning the Bisinger's home down to the smallest detail. This is done with the aid of CAD, which stands for Computer Aided Design.
Once the design is completed, we display a so-called data set. At the control station, we can then feed this directly into the machine so the drilling and milling is carried out automatically in the exact places we have specified in the design.
The computer-controlled production starts with the wood refinement process. Here, the glulam beams are cut to size according to the plans for each individual house. Every single component is given a number, allowing it to be assigned to a wall, ceiling, or roof element of each particular prefab home. The house elements are produced on the so-called wall assembly line and in the roof production section. In these gigantic halls, around 100 employees work in 2 shifts. As Deputy Production Manager, Anton Wörtz's job is to make sure that the house elements are manufactured on time. This begins about 8 to 10 days before the prefab home's delivery date, so it's just-in-time production. The first production stage is a semi-automatic machine making the wooden frames for the walls.
The next step is displayed automatically here on the screen so that the machine operator knows which step comes next.
This machine places wooden frame sections between the beams, moves them into the correct position, and then nails them automatically into place. Some are positioned by hand. They have assembly holes which other house walls will be docked into later. Once a wall is finished, it goes to the next processing station along with the plans. There, a plastic foil is drawn across the internal side of the outer wall. The rolling machine automatically staples it down immediately. The foil serves as a vapor barrier to prevent inside moisture from penetrating the house walls. The foil over the window openings is cut out by hand. Pre-milled chipboard. In technical terms, the interior cladding is now placed over the foil. A worker aligns them by hand, and a machine staples them to the wood. Based on the CAD data, it knows exactly where to shoot the staples into the beams. A layer of plasterboard is now attached to the interior cladding. This is to provide the base for wallpaper or tiling. At the same time, the machine cuts holes in the wall for power sockets and switches, in the exact positions specified by the designers. A so-called butterfly table now turns the wall over so that the exterior side is facing upwards. Electricians now install the sockets for the light switches, thermostats, roller shutter switches, and power points. The wiring is also fitted into the wall. For heat and sound insulation, the workers now lay mats of mineral wool in between the frame supports. An airtight membrane known as a synergy foil is now laid on top of the insulation. This allows moisture to pass from the inside to the outside, but not the other way around. Cement-bonded particle boards are now put in place and nailed down. They are completely waterproof. At the top and bottom ends of the wall and around the windows, aluminum edge trim is attached as edging for the polystyrene sheets that will carry the exterior plastering. One employee sprays the adhesive onto the cement-bonded particle boards, while two others lay the polystyrene sheets on top. A 50-kilo roller makes sure they stick together permanently, and then, just for good measure, they're stapled down as well. The wall is then raised up into a vertical position to enable the windows and the patio doors to be installed.
Here you can see the windows, just as we get them from our supplier. In other words, the roller shutter is mounted on the top, the lateral guide rails are already fitted. What we now have to do is to fit a sealing tape inside. After 5 minutes, this will expand and guarantee that the connection between the wood and the window is airtight.
With the help of suction pads on a crane, the fitters lift the heavy patio door into the opening, align it, screw it tightly into place, and seal it with silicone. So that the interior walls can be wallpapered, plastered, or tiled after the house has been built, a plasterer fills the joints between the boards. He works a strip of fabric into the filler so that no cracks can form later. At the next station, two workers apply the base plaster to the exterior side of the wall. One sprays the plaster on, while his colleague puts fiberglass mesh on top of it, again, to prevent cracks from forming later. Cut off the excess fabric, smooth it all out. Job done. The company's sanitary section is where installation walls for bathrooms and toilets are put together, made of welded metal frames on chipboard. In these walls, the plumbers install the cisterns and wastewater pipes, as well as the water supply pipes, which are also provided with insulation. To make sure there are no leaks, plumber Gökhan Gül pressure tests the system with air.
In this case, it's just under 4 bar, and if this pressure doesn't drop for the next quarter of an hour, the pipes are watertight.
The test is successful. Finally, the plumber insulates the cavities. In the meantime, the base plaster is dry, so it's time for the final rendering. This work has to be very precise so that the house facade does not look uneven later.
The difficulty with plastering walls is getting it done evenly. There are various ways to do it. Some do it in one spraying process, others do it in 2.
In this case, the plasterer does it in one step. Now the exterior wall is ready to be transported to the construction site. In another hall, the company is manufacturing a special product, a tiny house. With a living space of 14.5 by 4 meters, this prefab tiny home can accommodate 1 to 2 people. And what's more, it's delivered by truck in one piece. Hence the name, Flying Space. Depending on the size and furnishings, this type of mobile home will cost between 50,000 and 130,000 euros.
Here we have a module that was designed as an extension for an existing building. It has the same linear expansion, so we can quite easily combine such modules in width or in height to put up offices, living accommodations, or use them to design self-sufficient freestanding houses.
The Kohlers from Wilsingen, about 70 kilometers south of Stuttgart, bought one of these houses. Until a few years ago, the retired married couple had lived next door in their large detached house.
As we got older, we began to think about where we wanted to spend the years we have left. We originally thought about moving into a town, but then our son happened to get a job here in the area and was very interested in settling down here. So then our idea was, okay, why don't we just put a small house on our land here and not move away?
Dagmar and Armin Kohler's new home cost them around 120,000 euros, turnkey and ready for occupancy. 49 square meters isn't exactly generous, so clever solutions were required, in the kitchen for instance.
We decided to put the module here, in the middle, on wheels, so that we can push it on one side and occasionally have a dinner party with a large table in here.
And here we have another room that we use as a kind of study. We wanted to bring our old bureau from the other house, so we could sit in here and relax, read, use the PC or whatever.
For the tiny bathroom, the Prefab company has come up with something special. The sliding door in front of the shelves doubles up as the door for the shower. Next to this is a utility room, which is also used as a pantry.
This is our bedroom, small but cozy. You get a new sense of closeness when space is a bit tight. Under the bed, we've got 2 storage boxes with our suitcases inside. And behind this curtain, there's a shelf unit that's our wardrobe. And that's all we need.
The house has underfloor heating, but the Kohlers hardly use it, usually preferring to use their wood burner instead.
We really feel at home here. It's enough.
Yes, enough for our needs.
The tiny home was delivered by truck fully assembled. A truck-mounted crane simply set it down on supports that had been set in concrete.
When the house arrived, the pipes that had all been prepared in advance were just docked on. There was a box underneath the house which was connected up, and within half a day everything was ready. And we could turn the taps on and the water was running, or switch the light on. It all worked.
Back to the Prefab house factory in Swabia's Hohenstein-Oberstetten. The elements for the Bisinger's house are being loaded into several containers for transport. A worker secures them to prevent them from slipping and falling over.
Container number 1 usually has the ground floor inside. In truck 2, there are materials for the house interior, such as stairs, tiles, dry screed, etc. The next vehicle has the ceiling, and the one after that usually has the attic, but in this case it's the second floor of the house. Then there's another ceiling, and last of all, the roof.
Meanwhile, at the Bisinger family's construction site, truck number 3 is just arriving. It's carrying ceiling elements. Before they're installed, Udo Renner and his construction team have to put a double T-girder into place between the dining and living rooms.
The ceiling elements coming in now shouldn't span such a great distance, because if they did, they might sag in the middle. So that's why we need to put a girder in underneath them to support the load.
Now the crane lifts the ceiling elements onto the ground floor structure. That takes just under half an hour. But the final element doesn't fit onto the exterior walls.
A minor problem, the girder is protruding over the wall edge. We'll just have to shorten this board so it'll fit into the wall properly.
The minor problem is quickly solved with a jigsaw, and everything fits into place. The construction team fastened the ceiling elements onto the walls with plate head screws. The outside insulation is still being fitted. Assemblyman Kevin Renner pulls a ceiling foil over it and tapes it down. And in the meantime, the Bisinger staircase arrives and has to be carefully threaded through the opening in the ceiling.
Of course, that has to be lowered carefully so we don't hit the walls anywhere. And because such a staircase is quite an expensive piece of work, we need to be a bit careful when we lower it down and just make sure it fits perfectly. Stop, stop, stop. Careful, careful.
Vorsichtig, vorsichtig.
Okay.
After turning and pushing it a few times, it goes in without any problems. Udo Renner screws down the top of the staircase. His clients are delighted.
Incredible how fast the first floor of the house has been put up. Amazing. I'm overwhelmed, and I'm freezing.
The end of a good day's work. Just after 6 o'clock the next morning, once again, freezing cold temperatures of around minus 15 degrees. But today, at least the floor they're working on isn't covered in ice. The first of the upper story outside walls arrives. It needs to be positioned perfectly so that the remaining 3 walls can be connected to it properly. The walls are only sealed completely when the temperature is higher than 5 degrees.
This joint here is sealed with a sealant. This here has to be filled with foam. And after that, a corner bracket will be plastered in. Once it's dry, plaster goes over it, then the facade will get 2 coats of paint and we're finished.
Only 2 hours later, the entire outer shell of the second floor is completed. The team now moves on to the interior walls and to the installation wall with the cistern, the mounting openings for the toilet and wash basin, as well as all the water and wastewater connections. Another hour later, and the ceiling is also finished. The Bisingers now show their 2 daughters, Mia and Julie, their new home.
Show me your room. Is it this one?
No.
Yes. What's over there? When Grandma looks out the window, you can wave to her. What do you think of your room?
Nice.
Nice.
While the children are already looking forward to their new home, the team starts preparing to assemble the roof. The hip roof chosen by the Bisingers needs a special ridge purlin support. The roof consists of 20 individual components. The roof overhangs are even already painted. The construction team places the roof elements onto the ridge purlin at the top and the wall plates at the bottom.
Kevin, you'll have to lift it a bit and get further round. The first element has to sit perfectly so that all the others after it are always in the right place.
So it's raised again briefly, adjusted by a few centimeters, screwed down, and that's it. But then the 4th element suddenly gets stuck. Even pushing it back and forth doesn't help Kevin Renner and Father Udo. It takes them a while to find the root of the problem.
There's a batten here, and this beam goes up here diagonally, and the batten up here goes straight across it. So now it rests on this one here, and I can't get the roof section any further over. It's a design fault.
But only a very minor one. That's much easier to remedy than it was to find. For the construction team, the rest of the roof is child's play. By late afternoon on the 2nd day of building, the roof is finished.
It is, of course, very cold, but in the circumstances, everything went really well. Over the next few days, we'll get the roof tiles fitted, so the outer shell of the house is completely finished.
And then the craftsmen will start with the interior work. They'll need about 4 to 5 weeks to lay the floors, panel the ceilings, paper or tile the walls, and install the bathroom. After years of planning, the Bisingers will finally be able to move from their rented apartment into their own home. But now they'd like to inspect their prefab home from above. Site manager Tobias Rist sends them up 17 meters high on the cherry picker.
Awesome. It's so great to see the house at last. We've spent 5 years planning it, and in 2 days, they've built it up from nothing. Pure genius.